Today I will be explaining the transformer architecture, how it processes the input text and generates a new text like GPT and Gemini models too. So to give the overview of the transformer, what it does, it takes the input prompt and then it takes that prompt, process inside it, and then generates the output text. But the thing to know here is that it don't generate the output text whole text at a time. It generates it one by one, means first it will generate dear, then Sarah, then comma, and then next line. So the text generation process, as you can see in the ChatGPT as well, it's generate one token, or you can say one word at a time. The whole sentence is not generated in the single go. So we will discuss how this happen. Means what happen inside the transformer, it takes the input prompt, process that prompt, and generate one word. Then that word will go again here with the input prompt, and then transformer process the whole thing again, and then generate the new word. So then later this word also goes for processing to the transformer, and then process, and this step continues until the last token get generated. So now we will see what actually is there inside the transformer block, how it process all those things, and how it generates the human like text. So as you can see in the transformer, there are three components. One is tokenizer, another is stack of transformer block, which consists of multiple transformer block. Most of the processing happens in this block. Then we have the LM head. We will discuss each of the component one by one. And so as all of you know that computer don't understand the text, we need to convert them into the numbers too, so that the computer can understand those numbers. So for converting text to numerical format, we can use tokenizer. Tokenizer, what it does, it converts it actually tokenizer breaks the whole sentence into multiple small tokens. You can say it as word or subwords, so that we can process those words. So as you can see here, the bird based model tokenizer something looks like this. Here the sentence is English and capitalization unknown. There will be some characters here, so maybe that tokenizer also converting it as unknown token. Then we can also see the how GPT-2 process the text. GPT-2 mostly it convert the whole sentence capitalization into four tokens, which one token is cap utilization. Then it converted that whole sentence into small number of tokens. So here are the how tokens look like. Here you can see here. Then GPT-4 tokenizer, you can see is little bit different than the GPT-2, and is looking better than GPT-2. So what actually tokenizer does, here you can see uh, we have a input text. Then tokenizer encode the each tokens of the text into token IDs. So each word or subword is converted into token IDs. A number is given to them, and then we pass those token IDs to language model. Then it generate the another token ID, because model process the input numbers, these token IDs, and generate the token ID. Then we need to decode that token ID, that 1394 token means, or this actually handled by the tokenizer itself. So what tokenizer does, it encodes the input text and then we pass it to the language model, and then language model also generate the uh, token ID, and which tokenizer then decode that token ID into the word again. So you can say word, convert it into number, token IDs, and then convert that number into again word. This whole process is done by tokenizer, as simple as is. So as you know what actually tokenizer does. So here we have input text, we convert them into token IDs. There are multiple vocabulary is there inside the tokenizer. You can say token vocabulary means the total number of different words, subwords known to the tokenizer. So here you can see 0 to 50,000 means a total 50,001 words is known as the tokenizer. So it given it to ID 0 to 50,000. Then uh, after tokenizer there is a stack of transformer block where multiple transformer block is there, which process that input numbers, or you can say token IDs, and that generate the context aware output tokens, token IDs, and then we pass that into LM head, and then LM head process that token and give us the output. But the problem here of the tokenizer, you can see that as we only map a number to the tokenizer, uh, to the input text, so the context of the sentence is not maintained here. So we then use token embeddings to convert that token IDs, or you can say tokens, into meaningful context aware vectors. Generally token embeddings is used to map the token ID into context aware vectors, which means similar words have most nearly similar vectors, so we get the context aware information. Later LM head process that output generated by the transformer block, and then we pass that generate the token probabilities for each of the token IDs. Then we select the highest probability on the configuration of the system. It totally not depends on the taking considering the highest probability word, but for currently simple understanding, we are using the highest considering the highest probability word will be selected, and then it rendered to the user screen. So this is the overview of the transformer architecture. From this image you can easily, and we can summarize the whole thing is that we give input prompt to the LLM, then it process that prompt and then generate the probability for each of the word, and we take the highest probability word, and then that will be rendered to the user screen. So now we will see how actually the transformer knows that what actually user wants, means how it finds a relationship between the prompt and the generate the output. We can see this in the next video. Stay tuned.